How's everyone doing? I know these are all going to be rhetorical questions, so I'm going to keep talking. My name's Andrew. I'm a systems engineer, and I work for a company called Solace. We make an advanced event broker and a platform around it to help you build event-driven applications, enterprise-grade event-driven applications. So just a little bit of background on this talk before I jump in. As a systems engineer, I do a lot of work for proof of concept stuff and pre-sales work. So developer workshops or demos and that kind of stuff. So I have to build a lot of small projects pretty frequently. That's basically what my job is. So JavaScript has been invaluable to me. There are libraries for every part of the stack, and they all play very nicely together. So it's my language of choice. I've been using it for around 4 years. And I'm going to give this talk, event-driven JavaScript across the stack. And what I hope for you to take away from it is just a list of the libraries that I've used. I found a couple good ones that are pretty useful for a lot of different demo use cases, as well as seeing how easy it is to connect all these applications together using Solace, which is the technology in the company I work for. If you haven't seen event-driven programming before, just stick with me, try to learn something new. And I apologize for any sirens in the background. I do live in the city right now, so I'm not sure if there will be more. All right, I'm going to get started. So, yeah, off the top, let's give an overview of the demo I built first before I jump into the libraries. So I was assigned to an account, and they had an Industry 4.0 use case. If you're not familiar with what that means, it just means that there's a trend right now in industry to connect everything, and then to use that data using whatever tools we have at our disposal to make intelligent business and manufacturing decisions based off that raw data. So this prospect's use case, they had factories spread across regions, and then they had a central HQ where they had their engineers and management work, as well as their on-premise computing environment. So basically what they wanted to do is take the raw data that was being produced in those connected devices at each factory, funnel it through some magic infrastructure, and spoiler alert, and then eventually get it to HQ in their on-premise computing environment so they can do things like store it, classify it, aggregate it, or potentially alert out engineers or interested parties in the data or the data products produced from the raw data. And of course, they want real-time command and control dashboards because this is 2020. I mean, what else are we going to build, right? So my job as a systems engineer was this. First was to come up with a semi-realistic problem that was relevant to their use case. The second was to design a solution to that made-up problem that proved and visualized how my company's software supports the protocols and event flows required by that prospect's use case. And then lastly, my job is to build it. So quickly, I'm going to go through the dummy use or problem that I posed for myself to solve. And it looks something like this. So I said, let's determine a factory's product output based on how many boxes exit the factory on a single conveyor belt. And you see at the bottom, I'm waving my hands and the boxes are neatly separated. So I might look something like that, and then display the product counts in real time on a dashboard for your engineers, your technicians, management to act on, and potentially send signals, command and control signals back to those sensors. So if we pick apart this solution, there's a proximity sensor is what you call it, and that's a connected device that emits a constant stream of distance readings. So we need to take those distance readings and then interpret them somehow. We want the product counts, right? So what that would look like is this. So if there's no box in front of the sensor, the wave is going to hit the back of the conveyor belt, and that'll be the baseline distance. And then if a box passes in front of it, well, the distance will decrease. So that's going to be a triggered state. And then once it finishes passing it, it'll revert back to the baseline state. So the distance is great, but it means nothing to us unless we interpret it like I just explained. So we need some sort of application for that, a stateful application. And then for the final component, for the dashboard, we need to take those interpreted proximity readings in product counts, and then in in some way push them to the dashboard for then engineers and management to be able to act on. And what that looks like is we're going to predefine some intervals that in our state machine, we're going to publish out the product counts that we were producing from those streams of raw data. And then we'll reset the count on the interval. And to note, this is real time. So we're pushing out events to this dashboard. The dashboard isn't pulling a database. And the product count example isn't perfect for this, but it's good enough to show that this is how it works, right? The big point here is the event flow, not exactly the dummy problem. So recap, there are 3 things I needed to build. So I had a proximity sensor, a connected device, that's IoT. There's a basic processor application, and then there's a dashboard component. So given that it's 2020, I'm going to use JavaScript for everything. I'd be crazy if I didn't, right? And then I also needed the data to flow like this. So I have from the proximity sensor, I'm going to publish raw proximity distance readings to that application that's going to interpret them. The processor is going to send the product counts in real time out to that command and control dashboard. And then potentially, if an engineer wants to, it should be able to send a control out to those proximity sensors. So if I were to build this using REST, that'd be pretty difficult as I scaled out my number of proximity sensors. I would need some sort of way to identify and then communicate with these individual sensors. Maybe I expose an API. I don't really know how I design this. So you can just use Solace for it. It's so much easier when you use Solace, right? Or event-driven architecture. So this is what the architecture diagram of the demo looks like. You have n number of proximity sensors that are integrated with a Raspberry Pi board, and I have a Node application running on that Raspberry Pi, right? So from there, I'm going to publish the proximity distance readings into my event broker or message broker, if you're more comfortable with that term. And then from there, I'm going to subscribe to the topic that these distance readings are being published on and receive them in my proximity reading processor. I'll interpret them as product counts and publish product counts on an interval back into Solace. And then from there, I'm able to receive those product counts on my React dashboard. And if I click a button, I'd like that to traverse back and traverse out to the proximity sensor that it's addressed to. So notice how Solace is taking care of all the topic routing and the filtering and the connectivity details. So I have a quick video of what that looks like. So here's my table. I click into my sensor, and then you can see that the product counts are starting to stream in real time. And then if I click stop, so I issue a command, that's going to send it out to the sensor with this ID. And you can see that the product counts are starting to go down to 0. And then when I restart it, it'll start sending back out accurate product counts, right? All right, cool. You probably care more about the JavaScript stuff, so let's get to that. So first, what JavaScript libraries did I use to build the proximity sensor app? Johnny 5. So Johnny 5 describes themselves as the JavaScript robotics and IoT platform. And I will tell you that their API is dead simple. In a nutshell, what it is it gives you callbacks for different types of connected device events. So the callback triggers whenever that board event happens. And it's been tested against Arduino compatible as well as non-Arduino compatible boards. So that means you get a lot of bang for your buck with this library. So if you learn Johnny 5, you basically have a Swiss Army knife tool that you can apply to any IoT use case or demo that you may need to create, right? It's got a pretty good community as well at over 10K stars on GitHub. And then specifically, if you're interested in building out a proximity sensor like I did for my demo, my manager put together a really thorough code lab that walks through the setup, assembly, and purchasing instructions that I used for this demo. You can see the board name here, link to it here. In Code Lab, it's like a code tutorial with screenshots and sections. It's an initiative by Google, but we at Solace have a couple code labs, and you can see them there as well. So next up, let's just look at the processor. application. And for this, I used XState. So XState is a JavaScript library for state machines and state charts. And as you can see by the NPM trends chart, it went from, I think, 50K to 500K. This library is absolutely blowing up in the community. It's super popular, both in front end, and now it's starting to creep into full stack a little bit. So I only have 25 minutes here, so I don't have time to do it any justice, but I'll give you 3 benefits of using a state machine right now. An explicit state machine is easier to reason about than an implicit one that's spread across your code base. And all applications are a state machine, so you can't say that my app isn't a state machine. State machines represent your application state as a graph, which lets it be visualized. And this is a bigger benefit than you might think. If you're sharing your code with a bunch of developers and you just shoot them a link and it's a visual of the app state, how powerful is that? And then you can just dive right into the area you need to. And then lastly, you have state machines prevent illegal states and illegal transitions because everything's explicit. So my workflow for using this was to first jump into the visualizer tool to model the processor states, right? The boxes passing in front of that sensor, the baseline state, the triggered state, the intervals, all that's handled with the XState. But I started at the visual tool, then I implemented the actual logic. And I think that's a great workflow that more people should embrace. Next up, let's check out the React dashboard. So I used recharts for the charts you saw. There are a couple good charting libraries in React, but this one's built on top of D3. It's the most popular one, if I'm not mistaken, at 13.7K GitHub stars. I don't have a ton to say about it, besides that it's very easy to use. React window, pretty much the same. The lists you saw were React window. This is my go-to library for anything list related. If you're not doing something super complicated, this library is probably more than enough to handle your needs. And then this might be the most tangible takeaway from my talk if you're a React user, is use Immer. I found this library thanks to someone on Twitter, I forget who, but think immutable use state. So if you look over here, instead of calling set the state with the tuple that it returns, it gives you basically produce if you're using Immer, if you're familiar with that. But dead simple API for immutable state in React apps. Awesome library. Can't recommend it enough. And then lastly, the common libraries across all the apps. So if you noticed, I have these purple boxes with MQTT in them, and they sit between every single application and Solus Pub Sub Plus. So I guess I'll start here. So if you're asking what's MQTT, it's a protocol that was designed primarily for an Internet of Things, like lightweight pub sub message transport. But it's more generic than that. And a lot of people describe it as a protocol that doesn't do too much and it doesn't do too little. So my advice to you is, if you would like to learn more about event-driven programming, especially with JavaScript, I think MQTT is a great place to start. It's a really good protocol. It's got great community backing, and it's going to expose you to a lot of different ways to program or to jump into event-driven programming is what I wanted to say there. So, and then lastly, Immer. So if you use JavaScript, you probably want immutable data types. Immer is a crowd favorite right now, and it has a dead simple API. Next up, so let's look at the event flows. I showed you a demo of it. First, I have the sensor publishing into Solus using MQTT. I have my processor application, and its XState here is MQTT in and then MQTT out. I have MQTT out to my recharts, the chart, and then I have MQTT out to my sensor from React, from the button press. So what does that look like in code? Something like this. So if you navigate, excuse me, I forgot a slide. I'm going to jump back to it. MQTT.js is the MQTT client for Node.js in the browser. And I found that they have the best docs in terms of MQTT clients. So if you've never used one before, start here and look at all the event callbacks that you get, because they do a great job at documenting it, and client lifecycle events you get. But basically, you just need to connect a client to the broker using whatever credential, using a host URL, username, and password. And then that's it. You can subscribe and publish. So you subscribe to a topic, and then anytime another application publishes a message on that topic, the subscribing application is going to receive it. And in 25 minutes, I don't have a lot of time to dive into why this is a really good way to build applications. But if you Google Solace in topic hierarchy best practices, you'll be able to learn a lot more and see how it really buys you a lot. So your microservices are then completely decoupled. You're able to scale out. It's error handling. Your microservices don't have to think about retry logic. They get to stay to their single purpose. And it's just a really, really easy way to build things, because all you do is kind of you pick apart. I'm jumping back to the architecture diagram right now. You pick apart the problem. You look at what you have to build, and then you just assume that everything can talk to everything else because you have an event broker that's doing that hard work. So Solace supports any-to-any protocol translation for the protocols that we support. So while I used MQTT for all these different applications, that didn't have to be the case. I could have also used AMQP, WebSockets. I could have used REST if I needed to. So when you have an event broker, it opens up just a ton of doors to just build things at an incredible speed compared to if you had to think about APIs and point-to-point connections and then trying to scale that out. It's a nightmare. So once you start programming and building things using an event broker, you really can't go back. Yeah, that's about it for my talk. I will say I love JavaScript because it has open source libraries across the stack. It's super easy to use. I can use it for my web development. You can get into arts, graphics, animations, Internet of Things, data visualization. You can see, and then the more serious stuff, right? Functional programming, state machines, and server-side frameworks. So it's really a language that acts as a bridge across the stack. So all your developers can share, can teach each other. You can. It's really good in terms of a team dynamic. But then the problem is when you have all these different libraries to choose from, that's not always a good thing. Like maybe you get the factionalism between React and maybe a Vue fan or an Aurelia fan, right? But if you have an event broker with any-to-any protocol and API translation, all these different libraries connect with each other super easy, and then you can just keep building awesome things, which is really what you want to be doing as a developer, right? So with that, that's about the end of my talk. If you scan this link, you'd be able to sign up for a Solace Cloud account, which will give you access to a fully featured event broker, which will help you build the things that I showed and connect into it using MQTT. I'm going to quickly play this video. So if you looked at the MQTT client config, you saw that there was a host URL. So I'm going to show you from scratch. I'm spinning up a service, and I'm going to show you how to reach that URL, I think. So I select a region. I'm going to enter my service name, all the talks, example. And this is entirely free tier, by the way, no credit card required. So great, my service is up. And then if I go to the Connect tab, you can see there. So you get all the connection details pre-populated, copy pasted into your MQTT client, and you're off and off to the races. Leave that up for 2 seconds if you're having a hard time scanning it. That's the link if you want to pull out your phone and scan it. And then also we have a developer site for all things event-driven architecture. We have JavaScript examples, messaging basics if you want more of an in-depth materials around that, Solace and more. It's a good first stop for developers. You can scan that or Google Solace developers. I've included some additional resources if I do get to share these out. I will probably share this deck out on my Twitter, and you can see my handle there, Andrew_Bytes. And with that, I will open up for some questions.
Well, thanks, Andrew. Appreciate that. I've got a couple of questions here. I'll read them out. The first question is, where can I learn more about event-driven architecture?
I would say the Solace developer website is best. You can see even under here, use cases, what is PubSub, resources. So it's not just about our product. We really talk about event-driven architecture in general. We give you a very wide overview of messaging basics, what a topic is from the very start. So I would start with this website for sure.
Okay. The next question here is, what alternatives did you have other than XState to manage the state of your application?
That's a good question. I could have just used local variables and a bunch of guards and conditionals, right? That's how a lot of people would have built it. But recently I've committed to learning state machines and trying to understand or just get better at them. And once you get familiar with the API that it exposes in the different parts of a state machine, it's pretty much the same as just using local variables and conditionals and guards and that kind of stuff.
The next question here is somewhat related to the same topic of state. You used StateX. Would you recommend against, for example, VueX if you use Vue because StateX works for all frameworks? That's
right, and I would say stick to things that you can use across your stack. Why would you don't want to be locked in to a single framework? Just like you don't want to be locked into proprietary technology. So you want to keep everything open. You want to use open protocols. You want to use libraries that you can share across the different applications in your system whenever possible. And it is possible here, so I would recommend using XState.
Very good. I don't see any more questions at this point. Let's just give it about a second or two to see if anything else pops up or if anyone has a follow-up question. Nope, I don't see anything. So thank you so much for your time. Appreciate it.
Cheers. Everyone stay safe, stay healthy.
We're running into a break at this point, so we'll continue right after the break. Thank you.